Hello everyone. Good morning, good afternoon, or whatever, whichever time zone you are. So hello for the very first fully in English lecture from our channel. So the lectures are called FPGA from zero to hero. We did like 30 Turkish lectures. Now we are starting to the English ones. So let me check the chat first if everything is all right in terms of video and audio. Just a second. Then I will start talking about the agenda. Yes, is everything fine? Kamer, Talha, Orhan, Furkan, could one of you answer if sound quality is good, video quality is also fine? Okay, thanks. Thanks, Talha. So, today, let me a little bit make my video smaller. Okay, lecture 1. 8 major steps of FPGA design and verification. So, here is our agenda. Let me try to fit my video to that space. Okay. So today we will like 10-15 minutes I will talk about the course details, kind of course introduction. So I will explain what we are planning to do. I will give some examples what we have done recently in the Turkish versions of these classes. Also, if you would like to watch them with subtitles, there is also some nice subtitle option. So in like 100 plus different languages. So you may try, but yeah, you know that AI stuff is not that good, so it's not perfect. You may also wait for the English ones, but the curriculum will be similar. So I will explain that in detail. So the course introduction section. Then we will talk about FPGA design and verification flow. Actually, I will explain it on a kind of diagram I draw in the past. So I have updated a little bit. Oh, by the way, it's a live document, so I update it time to time. Like 5-6 years ago, I first shared it on LinkedIn. Then nowadays, like in June or something, I shared it, a newer version. So I try to update it, yeah, as far as I learn, as long as my colleagues give some recommendations, etc. So yeah, I think, but in my opinion, it is a solid one. So we will focus on that together, like 30 minutes, 40 minutes, or something like that. Then I will talk about, yeah, let me a little bit make this presentation screen smaller. It is not fitting right now. Yes, now it shall fit. Also, I can a little bit make my video bigger. Okay, that's better. So the third one for today, task and version management, and plus CI/CD. So I will mention 3 tools that you shall use, and you will really actually, in my opinion, extremely benefit. So in terms of many things, I will explain in detail. So this is the third one, and the last one we will wrap up, and I will check questions in the chat box. And also today we will have another lecture, another class at 1 p.m. That's Greenwich Mean Time +2. So it is like right now, yeah, any major cities in Europe, like Berlin time, like Amsterdam time. So it is GMT +2. So at 1 p.m. today, we will have the Q&A session. During the Q&A sessions, I will also take speech. Yeah, you can ask using your voice, using your microphone. So yeah, via Discord, we have a setup. So also the ones listening or watching the lectures on video, they will hear your voice. So that more interactive Q&A session is actually today at 1 p.m. and during the course introduction, like in 10 seconds or something like that, I will explain that in detail. So okay, this is the agenda. So this is the 29th of September 2024. Yeah, like we in 15 weeks or something like that, we will complete this FPGA from zero to hero series is in English. So yeah, depending on the comments, likes, interactions, I may do another one, let me say, course, which will have more, which will include, which will cover more advanced topics. So we shall discuss that towards the end of these 15 weeks. So okay, next slide. Let me check this video ratio and a little bit fix it such that it fits better. Okay. So yes, I saw Talha shared the English Discord channel we have. So right now I will also little bit inform you about that. But thanks Talha for sharing. So about the course, we will have, as I mentioned a few minutes ago, yeah, there will be like 30 classes, 30 lectures in total. Each week, like one course class and one Q&A session. So it is like, as you see here, week 1. If it is special for today, we will handle both. Or this Sunday, we will be having not only the lecture class, but also Q&A session today. So as you see, we started 10 a.m. GMT +2, and at 1 p.m. We will have the Q&A. So I added, since I created these live streams, I also added here. Also, each course description, I am adding this curriculum plus the name of the lecture and their dedicated time. So usually it is like we will be having, this week is special. This Sunday is special because we will be having both, as I mentioned, class and the Q&A session together. Little bit time in between to rest, and for you, for the new learners of FPGA design and or verification. So you shall digest it a little bit and ask your questions either using the chat box or the Discord voice channel. So for the Q&A, there are two options like that. But during the course, I will check the questions at the end most of the time. So in order not to make the class, the lecture so long, so we will try to finish it in like 1-2 hours. So depending on the topic also, I will check the questions like in each 20 minutes or something like that. So if something major is misunderstood, or there is a really nice question, I may stop and answer. But otherwise, for the questions and answers, we will be using that dedicated weekly Q&A course, questions answers. So just a second, let me open the GUI of my camera. I will check something. Okay, let me take to the left side. Yes, it is on global. So sometimes it has autofocus, but since there are some photos in the background, so sometimes it loses the focus if I don't move. So yes, I am trying to check the OBS screen, YouTube live stream screen, etc. together in parallel, let me say. So yeah, the topics of each week is like little bit determined. So because most of them will be for this one. This is like a comprehensive class. So yeah, not beginner, but little bit between beginner level and intermediate level. So it is more like not teaching you a hardware description language like VHDL, Verilog or SystemVerilog in detail. It is not to how to write it. There are many nice beginner lectures available, free of charge or paid ones. You may get them online as well. But this course is more like I have 15 years of experience on FPGA design, and also like starting from actually 2016 or something, I got some verification seminars as well. So it is like a kind of SystemVerilog, because you know, for verification, SystemVerilog is becoming more and more popular. So like I think I took the first SystemVerilog class in 2016. Then I got some UVM trainings as well. But I used in the past OSVVM and UVVM, some hands-on experience. But yeah, I am more using SystemVerilog and UVM in last 2 years. So in terms of verification, yeah, I cannot say I have like this years of experience. But in terms of the design, yeah, for 15 years I involved in many different designs. So I worked with great engineers, technicians, also from ladies and gentlemen from other disciplines. So I worked in 3 really well-known companies. One of them, the first one is actually, I worked there for 10 years in total. Aselsan, it's a really famous and great Turkish aerospace and defense industry company. So there are many smart people there. It was a really pleasure to be a part of Aselsan, working with great engineers. Yeah, most of the time, yeah, also other stuff, as I mentioned, they were also outstanding, but I majorly worked with FPGA engineers, like also software engineers, also kind of PCB designers, analog designers, EMC, EMI designers, kind of, since this is my expertise. The FPGA one, that I worked with this kind of sub-disciplines, let me say. So yeah, after 10 years also I worked at Deutsches Elektron and Synchrotron, DAISY, which is located in Hamburg, Germany. So it is the actually German version of CERN, that research institute working on particle accelerators with many great scientists and engineers. So I also did FPGA stuff, majorly not only Aselsan but also Daisy. I did some cutting edge technology, image processing, signal processing, video pipelines, some sensor processings, etc. Yeah, majorly FPGAs. You know, or you don't know and you just started learning that FPGA is capable of huge parallel processing. FPGAs have multiple inputs, multiple outputs, so kind of MIMO structures. You shall receive different kind of signals, process them, find some features and share them with outside world, either using, you get data from sensors because they sense some real world signals, analog kind of. So, and at the end you process them and you either share that information digitally with other CPUs, FPGAs or other modules, sometimes with some cables. So wired communication or wireless communication, or you directly provide those outputs to some actuators. So like for actuators, very simple example is your microphone, the microphone I am using right now, it is sensing my voice, converting it to digital domain, and then those digital signals, actually there is no wires for this one, so it is transferred to the PC, then through internet you are getting it, but at the end, after you get it digitally, of course there are many technology lying behind that, but you are somehow getting it. Let's skip the details. At the end you have the speaker on your phones, on your PCs, in your PCs. So the actuators, they are translating those digital signals to voice waves, to waves actually at the end. And it is a simple sensor actuator example. Of course there are many. So let me drink a little bit coffee. Okay, so we will have 15 weeks. Actually, you may find the details of the curriculum on our web page. Actually, I am not using an external web page right now, but YouTube channel page. So it is like youtube.com/@falsepets. So this is our YouTube channel. Also there are nice watch lists there. So depending on the topics, I am creating some watch lists, so you can follow. For instance, today's first lecture and second lecture I already created. That's FPGA from 0 to hero, live 4K and free courses, English one, so you can use that. Also there is Turkish one, which includes those 30 lectures we had in last 2-3 months. As I mentioned, using subtitles, you may check some details, you may check what we have done. Other than that, depending on your comments, just don't hesitate to ask any questions through Discord link that Talha shared. Also, you may send direct messages from LinkedIn to me if you prefer. I would prefer Discord because many people will see them, and that will be a nice knowledge sharing. But anyways, you may ask directly to me as well. I will try to reply when I have some free time. But depending on your comments, we may little bit update the curriculum. So it is not a fixed one. So I will try to, because there are many positive comments at the end of our Turkish ones, Turkish FPGA lectures we had. So I will try to keep for the comprehensive class. I will try to follow this curriculum, but we can do some updates. For instance, if you say good coding practices and design recommendations shall be, instead of three weeks of lectures, shall be 4, if you say, I may update it a little bit. Or on the contrary, if you say, let's have it 2 weeks and let's add this topic, then I can also do that. So depending, also I am doing some good votings, the live ones, so weekly or bi-weekly, so we can do that to update our curriculum, our style. For instance, yeah, we may also, depending on your comments, we may make voice questions available during the classes, during the odd number of classes. You see here week 1, course 1, course 3, course 5, those odd number of classes. We will talk on the presentations I have prepared, or I will prepare. But during Q&A sessions, we will just full screen of my camera. We will just discuss the details, the questions. So it will be like even numbered courses. We will be having those Q&A sessions. So other than that, is there anything I missed? So depending on how you act, like if you ask some questions, if you attend classes on Discord, I am assigning you as moderator. Then those moderators, you know, you are not the, of course, owner, but you have some priorities in Discord channel. So you can do some, you have some extra actions, let me say. It is nice. So yeah, we have like 30 Turkish moderators right now in Discord. So we would love to have international ones. So it is, you know, as far as you discuss, brainstorm, share the knowledge, not only lecturers or the question askers, but also the ones answering or reply. So they are learning a lot. So this is our major motivation to have these classes live, so that you can interact via text or voice, and free of charge as much as possible. So it is, you can do it, you can watch it live. Everyone shall watch it, may watch it if they like. So yeah, this is our major motivation. So yeah, the TBD, that abbreviation is to be decided, but actually it is, I will today add all the expected dates. So like each Wednesday evening we will have the class. Like it will be yeah, the week 2 example is here. So next week, 2nd of October at 8 p.m. again, GMT +2. Yeah, it is in Turkey. This is 9 p.m. So, but I think, yes, this is summertime, so it is also called what was it? CEST, so Central European Summertime right now. So in a few weeks or 1 month, I don't remember probably it is at the end of the October. So it will stay in GMT +2, but in Turkey, since they don't use that summertime schedule anymore, and I am explaining this because Turkish students or engineers are right now majorly watching us, but I am hoping international ones to join in the future as well during next classes. So then that weekly classes will be starting at 10 p.m. in Turkish time. So be aware of that one, because yeah, I am usually working until 6 or something. By the way, I forget to mention that, sorry. The third company I am working right now, it is ASML. So I am in the Netherlands, Eindhoven, and I am in the, like, as I was in last other years, in total 15, I am also in a FPGA team. So but I had chance to in last 15 months or something, I am involved more in verification. So it is like, the story is like that. So 15 years I did like, let me say 90% of the time verification, 10% of the time, 90%, 95% design, FPGA design, 5% kind of verification, including, yeah, I am adding that 15 months experience on verification plus the trainings I had. Also, I had some hands-on experience on UVVM and OSVVM, so which are VHDL based universal verification methodologies. Okay, so this is first week, 8 major steps of FPGA design and verification. So second week, actually it is 3 days later, 4 days later. So Wednesday, next Wednesday, 2nd of October, we will have VHDL versus Verilog versus SystemVerilog. So this is we will be comparing and contrasting these 3 HDL hardware description languages. So I think that will be really nice. Like, I believe all 15 lectures, the content is really solid, but of course your opinion is more important than mine. But I got many positive feedback on this, lots of, let me say. That's why I am giving these classes also in English right now. So I had 1.6K followers 3 months ago on LinkedIn. I was trying to share some stuff, but after starting these classes, now I have 5.5K followers on LinkedIn. So many interactions have happened. So it is nice. Also, many Indian, Chinese, European, American, but majorly Chinese and Indian. Also some Paki people, they ask to make these live and free courses fully in English as well. So by the way, all the content, all the let me say documents we used, slides, etc. in the Turkish lessons is fully in English. So subtitles may help if you would like to pick one of those subtitles other than English. So you will be having all the content in English. So this is also a nice fun. We didn't use Turkish slides. We just spoke in Turkish during those 30 classes. So, but a little bit the length, the amount of time of those lectures are longer, because during those classes we are sometimes discussing things, actually criticizing ourselves, myself, also my colleagues, little bit to improve some design approach, verification approach, FPGA design quality. So yeah, that is why those lectures are longer. So we are little bit criticizing what have we done and discussing how we shall do much better. So yeah, that is the reason the total time of some classes is like 4 hours, 5 hours. But I will try to keep the lectures 2 hours, weekly ones in detail, each week. So I think 2 hours of pure lecturing, giving lectures fully focusing on the slides and technical details. Those were also some technical details, but more like a little bit our self stuff. So yeah, I think 2 hours, 1 hour and a half, 1.5 hours. So will be enough, quite enough for the classes, the Wednesday ones. But for the Q&A sessions, it depends on you. I think it won't be longer than 2 hours because it will be directly voice questions and text questions, text-based, voice-based. So I will try to answer. But if the answer of the question is so long, or maybe I won't know that, then I will forward you to people that are expert in that area. Either I will do that, or I will share you some links, some documents, such that we will get better information. By the way, it is usually like this. So you need to do, you need to have some hands-on experience. In general, listening is good to some level to get some insight, but you need to compile, you need to write some code, compile, discuss. So this brings us actually to the next slide of today. What shall you do in a planned way by following some steps? So it is the, let me a little bit make my video smaller. Yes, this is much better. So this is the FPGA design and verification flow I have drawn in the past. So it is like 8 steps. So the dark blue ones are the steps and the yellow ones are the outputs. Also we have a optional steps. Optional step here you see. Actually, thanks to one of my ex-colleagues, she mentioned, because always, yeah, after design, after some documentation, I have the approach of asking some reviews. So thankfully, she said that yeah, it would be really nice to have an optional step. So I added that one as well. So you may say it is like 8.5, so 8.5 steps, but this optional step is also really important because sometimes yeah, that designers are not that experienced, so that may help a lot as well. So I think at this point it will be nice to have a 5-minute break. Let's have a 5-minute break because we had the course introduction, we had the entrance first talk. So check-in, let me say, we had the check-in, we briefly explained the course. So this is the major topic that I will be talking on today. And also I have a few slides more, but this is the major one because it explains a lot. So let's have a actually 9-minute break. Let's continue. Yeah, it depends on your location, but for mine, let's continue 5 to 11. So like 9 minutes later, I will be talking on this really important slides, because it really affects your quality, design quality and verification quality. So after the break, let's focus on this one. So see you in 8 minutes, 5 to 11, 5 to 12, wherever you are. So we will be talking on this. See you soon. You can ask using Hello again. So we are back. I don't expect any issues, but please, one of our moderators, could you please inform me about that? I think there shall not be any problems, but oh, just a second. I hear myself from my cell phone. Sorry. Let me mute. Okay, I am also cross-checking if everything is fine from my cell phone as well. I think we are good. Talha, Kamer, Orhan, Gurtdereli, could you one of you please text about that? If everything is fine, I shall start. I am starting. I forgot to mention 3 things. I will start with them, then I will be talking. Everything's fine. Thanks, Orhan. So yeah, I forgot to mention 3 things. We have a whiteboard, as you see. So also we have a nice 4K webcam, the OBS bot one, OBS Tiny 2 it is. So it has a gimbal, it can move, also it can focus with voice commands. Let's try one. Position 2. Yes, as you see, it can focus. So also it has a nice AI interface, so it can track AI tracking, etc. But I am using these fixed settings because since there are, as I mentioned, there are some other photos on the wall, pictures also, drawings, so it sometimes tracks those. Yeah, that's why I am using fixed settings for the video. But let's go back to the, yeah, we can use this I am like, this one I don't think so for this class, but maybe in Q&A session in the afternoon, if you want me to draw and explain something, I will do definitely. So it is like I can do this here. Also on the desk I have this nice tiny whiteboard. So I have also, yeah, the normal whiteboard markers. So we can also draw. That camera can has a nice AI desktop mode. So we can draw if you would like to see something in detail. That, you know, sometimes those clock resets, data signals are tiny. So we may also try to do with this board as well on the desk. So we have this whiteboard option also. Okay, let's go back to previous setting. Position 1. Oh, this one not. Position 1. Yes. Now it captured the voice. So we have 2 nice boards. One of them is this one, Avnet Ultra 96 version 2 board. It has a nice Xilinx MPSoC Ultrascape Plus MPSoC FPGA. So it is SoC actually because it has ARM cores, hard CPU cores, multiple ones. That's why they call it MP, multiple processor, multiple CPUs there. That's why it's called MPSoC, Ultrascape Plus. This is the technology. So it is really one of the best in the market. Of course, there are much expensive ones as well. But this is 16 nanometer transistor technology of Xilinx. So they are quite fast. So they have PS side, programmable software, PL sides, the FPGA side actually, programmable logic. Also, there are really nice hard IPs in addition to that, all those subcomponents of the hard CPU. So yeah, these SoCs are really, really capable of doing many different things. So you are benefiting from the pros of CPUs, hard CPUs. Also, they have a real-time processor inside to do some real-time stuff using sequential CPU processing approach, central processing unit approach, let me say, because that processing P is also standing for central processing unit. So saying it again doesn't make too much sense. So let me correct it, like CPU approach, but in the PL side, programmable logic side, you have like, you may run your code, your main core clock, main clock at 800 megahertz. So it is like each 1250 picoseconds you can decide on something, because it is that registers the internal one of the major internal sources on FPGAs. Of course, there are lookup tables to make some decisions on using that lookup table structure. Also muxes, ASIC ones I am mentioning. Also there are registers. Also there are DSPs. We will be covering all of them in detail. Also we will be discussing about some good coding practices and design recommendations. So I will be sharing many links, Intel, Altera, AMD, Xilinx links related to do improve those stuff. But we have these boards. Also, this is Ultra 961. Also, we have a Turkish company custom board. This is a nice one also. This has a Phoenix FPGA. So it is actually, let me show you directly the board. Yeah, I have a nice that ESD protection here, as you see, in order not to burn any components. Oh, where is the? Yes, here it is. So this is, yeah, this is a student-friendly, low-budget board, like 120 US dollars. So yeah, let me also give some power, because as you see, I have some ESD production. These have some Ethernet PHY and RJ45 connector. Also, yeah, that Phoenix FPGA. So you see there's some built-in code there. So yeah, it has some micro SD card interface, etc. Also many input and output ports, pins, as you may guess. So we have two good, yeah, it is like the TriPi board. This is called TriPi from a Turkish company, Quantec. Also the Avnet one. They are like mid-range or low, yeah, a little bit low range, mid-range combination. But the for instance, both has some, not some actually, in both of these development kits, development boards, you may do many different things. You may realize tests. Also, you can do each and every step of this FPGA design and verification flow. Of course, in terms of verification, you need some other tools, but design stuff, you may benefit from the boards very well. So during the classes, if you ask for a specific implementation or specific thing to do, you may suggest it. So we may add that development boards content to one of those weeks. We may had also some additional classes depending on the the motivation, the intention, the expect of the majority. So of course it is not like if one person says that, it may not be possible because we have already a tight schedule. But if like 10 people, more people, I don't know, will be asking for it, I may update our curriculum. So also one last thing before starting to this one, we in the Discord channel, in Turkish one, we have many text and voice channels for some specific topics. So for FPGA, HDL, questions, answers kind of. Also some trainings channel about usually free of charge ones from Altera, Xilinx, Dulos, what was it? Yeah, there are 3-4 major other companies. I couldn't remember by heart right now. So also they are doing some nice classes. Yeah, there are some people like Jim Lewis, which is in VHDL, IEEE VHDL chair. So he is also doing all stuff about the OS VVM, open source VHDL verification methodology. So there is Espen Taleksen. He's handling with his team, of course, but he's at the top, on the top of that UVVM, so universal VHDL verification methodology. So this kind of really guru level people, they're also doing some free of charge seminars, webinars. They're attending to nice seminars. For instance, we had one of them I shared last week. Yeah, I've shared before, but there was nice event, FPGA Frontrunners. So it was a verification one. So many people from different companies did some presentations. So we will be sharing such events. So we have like, I think, 8 different text channels. So I will apply similar approach to our English Discord channel as well. So this was the third one about the whiteboards, Q&As, drawing them, development boards I have in-house so that I may use depending on your questions. Of course, I sometimes open Vivado or Quartus and do some compilations, do some checks. So we may do that kind of stuff as well. Okay, so this was the missing points I forget to mention at the beginning. So now let's continue with this important, very important, I would say extremely important FPGA design and verification flow. And if as I mentioned at the beginning of the class, if you have a question, urgent one, type it. I will try to, I have 2 screens, and left one is divided into 2. One is OBS, other one is the live stream. So I am checking the chat regularly. So if it is something important or not understand by majority or something like that, I will explain now. Otherwise, keep it for the Q&A session. So, okay, this is actually, okay, I draw it. I wrote all those text, etc. But this is, of course, 15 years of experience of mine with the helps of support of my colleagues, ex-colleagues, recent ones, the 2 other international great companies I worked, and the one I am working right now. So it is not the output of this flow is not mine, but many of those and some free of charge trainings, paid trainings, etc. So it is the result of 15 years, let me say. Of course, you may improve it. You may skip some parts if you think they are irrelevant, but I won't agree, to be honest. But depending on your time, depending, because engineering is optimizing everything, your money, your time, your resources. Then it is like sometimes macro, sometimes micro optimization. So you may improve this. Also, you may, since I am sharing uh, this flow after some updates on LinkedIn, you may provide some feedback to me regarding that. So any kind of questions, feedback, ideas are appreciated. So don't hesitate to comment or ask anything. So this is the way, let me say. We are learning, improving ourselves, and being better engineers. So first one is planning. As I mentioned at the beginning, the dark blue ones are the steps, green ones are the outputs. Since that area of each box is somehow limited, I try to write down the most important ones to me. Of course, this is not that easy. If you just do these 8 steps, provide these, but if the quality of those outputs are not good, so that won't mean too much. So this is why team spirit comes into the onto the table desk, let me say, because if you have a good team, like 6-10 people, good team leaders, because each team leader shall not have more than, ideal, let me say 6 in my opinion, but okay, let's have it 8 or something, because team leaders have to follow all the tasks assigned to those engineers. They somehow be the gatekeeper there. So in terms of the design approach, verification approach, rule sets of the company, reusability, so the team leads have really lots of responsibilities. So in ideal environments, they like spend, a team leader spends 90%, 95% of his or her time for their teams, let me say. Otherwise, if they try to involve in the designs, if they try to do also some micromanagement stuff, so then it is not feasible. But as I mentioned, as I explained during this class or the following ones, you shall understand it more, because I learned this by experience. So the team leaders are usually really smart ones. They are selected as the team leader. Of course, sometimes if they don't perform very well, not only team leaders but also designers may change their responsibilities or change their companies. I don't know, guess the details. But these are normal. So if someone becomes team leader, it doesn't mean that guy will not do design or verification again. It doesn't mean that. So also, I see internationally that mistake is done also. Someone becomes a team leader at some point and he or she is always team leader at that department, let me say. This is a big mistake, because if for instance designers or let's say if an FPGA designer is performing bad, okay, then they shall get asked to pay more attention, more focus. Maybe his or her future shall be planned, so that some support is required, but also that person shall work harder, okay, if his or her performance is bad. But similar stuff is the team leaders. Come on, someone is becoming team leader at some point. let's say when there are not enough experienced people in 10 years ago, then many other people hired, or the working ones improves themselves extremely, and still that low performing team leaders are there. So this is a big mistakes, but yeah, unfortunately in 2024 still some companies doing that, but let's skip that part for now. But that was important, because otherwise if team leaders are not really good, then the ones working under his or her call, then it is inevitable that they will also, that there is not a bright future for that team. Also, one last thing about this leadership stuff. Team leaders in any company, okay, they shall communicate really well. Not only team leaders, but also managers. Otherwise, yeah, the experienced one, even like 2-3 years experienced engineers, you may guess, if this communication is bad, it becomes something personal, then designers suffers from that, team leaders suffer from that, at the end whole companies suffering from that. So that should be in a good balance. Okay, you may not like your team colleague in person, but you are supposed to act in a professional way, and you shall maximize the throughput. So this is the way. Otherwise, it is like, sometimes it is like it happens. It is still happening in many places, you may guess. Yeah, that some silly personal stuff prevents the team from progressing. So that shall not happen. As I mentioned, anyone responsible from that they shall get what they deserve. It is not like that if it is a experienced one, then it is fine. No, it is not like that. If you do that, by the way, either if you gave some extra equality, let me say, for some people, either they are experienced or inexperienced, so then that team starts collapsing. So this is in my opinion inevitable. So yeah, that's self-criticism, also team spirit, that should be always there. Otherwise, you may try to do these 8 steps, but you will fail. Yeah, I observed that many times in the past. So my first recommendation before starting these 8 is that, so have a good team spirit, try to teach, try to learn, work hard, party harder. So party doesn't mean of course smoking or drinking alcohol. Don't misunderstood this. Party harder means enjoy your life. Okay, do some sports, enjoy yourself, go sightseeing, etc. Whatever you would like to do. But during that 8 hours of daily work, you shall really work. So this is my recommendation. Don't play with your cell phones. Don't spend time on social media. Try to focus, try to discuss, try to do some brainstorming. So by the way, it is the output of the second step. But let's start with the first one. So planning. What is planning? Let's say you got a task from your team leader, from your manager. Let's say sometimes these two are the same, sometimes not. Ideally, it is not the same, by the way. But let's say you got a task. For many years, I saw that as soon as a guy or lady gets that task, they start writing code. This is unacceptable. So you should, depending on the complexity of the task, okay, you should do some planning. Planning means, at the end, as an output, you need to have well understood, clarified design requirements. If it is really, or it is somehow necessary, let me say, okay, I won't be too strict about it. If it is necessary, those requirements shall be updated by team lead or team architect or system architect. So actually nowadays in this agile workings methodologies, there is a team architect, then teams like 10, 12, or how many you have in your company. Those teams, combining teams, becomes a train. They call it train. Then there is also at train level, there's a train architect. Also, there are many others in this big companies. There are these agile methodologies. So it is like more like you have not only system architect. I will fix that one, that system architect. I will update it as architects, because there could be team architect. At ASML now I have team architect, I have train architect, TA, I have system architect on the top of it, top of everything, let me say. And system architects is like 30 years of experience, kind of, because they know the system. Those systems are, each lithography machine at ASML is like $500 million. They are really expensive. Of course, there are cheaper ones, but it's really expensive and complicated machines. So they have many other titles, not in addition to architects, but we have 3 stages of architects. So this is why that $500 million lithography machine, complex, many sensors, many algorithms, many communications, they work very well. So because they have those roles, many others, we may, if you like, I may mention them in one class about these agile methodologies in terms of FPGA design and verification. So those many roles results in that high quality factor products. So this is the convenient way, let me say. So I will update this part, not system architect, but architects, because as I mentioned, depending on your company, on your approach, on your design methodology, Kanban methodology or agile methodology, or their specialized custom editions like we are having at ASML. So you may have different number of architects. Sometimes, let's say, team architects may skip it, but train architect may catch that and inform you about that, fix after some review, or requirements may come directly from system architects, then train architects doing some changes, updates on it, then team architects also does some stuff, and at the end you have a really well understood, clarified design requirements. So if you don't have clear design requirements, you shall not continue even to conceptual design, because you don't know what to do. You don't know what to design conceptually or what to verify conceptually. So this is why each and every step is really important. Of course, there are some ways to go back. For instance, if you are in level step 3 implementation, you may also go 2 step back for planning, because maybe you another requirement added at some point. But as this stuff gets complicated and every step gets many updates during the design cycle or verification cycle, then design quality is damaged, is degraded, because you should be solid in each step. Of course, that going back is possible. Updating, sometimes it is vital, it is important, but in huge professional companies, the best ones like ASML, like Apple, Samsung, Intel, AMD, and many others, of course they have maybe better approach flows, but this is just one page, so don't it would be misleading to compare, contrast it with their design flows. Of course, they have, like, sometimes you have 100 pages of documentation about your design styles, etc. But this is just one page one. So maybe they have better ones, but in general perspective, they are using something like this. Otherwise, by the way, check those most recent agile CI/CD. By the way, we have a class regarding that. CI/CD, that's like infinity like drawing. So it also has something like this, but this is more specialized from my point of view for FPGA design and verification. So you may, by the way, sometimes, yeah, this conceptual design. So also this is conceptual design and verification as well, because you need to then designing your verification flow conceptually. So some words maybe a little bit different for verification, but the main intent is having a nice major steps, starting with planning and ending up with the documentation. So let's continue. By the way, this ALM tools, this is important. So you need to use them, benefit them, so that you will have these requirements written somewhere, saved somewhere. Otherwise, yeah, it is not acceptable to extract some design requirements in some chats, let's say, or some meetings not recorded. Yeah, they should be written. They should be in an official document. Otherwise, yeah, they are changing. They say, they don't say it and they say it. Oh, we said that during that meeting, kind of, you know. So they shall be labeled official company documents, and this is a really, really big mistake that I have observed many times. Those first two stages are skipped because design requirements are not clear. They say that they will prepare their documents, etc. And you start from this implementation stage. And also you skip simulation. You do very, very easy, let me say, unsophisticated simulation, not even verification. And you skip also resource and timing optimization, design code reviews. These are majorly skipped. You just try a little bit in step 3, and little bit simulation, and you try to load your bit stream to that expensive machines. By the way, sometimes final products are like much cheaper, but the volume is much higher. So it doesn't mean that one company has that $500 million product, but others are less valuable. No, it is not, of course, because sometimes they sell just 1K product, but they sell billions of it in years. So design quality and each step of you see here always matter. So you should customize this, change it, but at the end you need to have something proper to follow. So planning is, I think, clear. So ask any questions if you don't understand. We may either discuss here or during our Q&A session. Also, you may ask during the Q&A session later this after a few hours today. So conceptual design is what? It is, by the way, how many hours or days you shall spend for each step is depending on your task complexity. So I cannot say that spend 2 days here, 3 days here, like 3 weeks here and 3 weeks here, kind of. Okay, there is a balance, of course, because some steps are again depending on the complexity of the design. Again, how many components of the design you are reusing, because the ones you are reusing shall be very, very solid. So they shall be designed, very well designed, and verified and qualified, system integrated design blocks. So you shall not questionize the components you are reusing. But I know this happens because there are many duplicates in many companies. Also, some companies are really tiny. They don't have any IP libraries or custom libraries. So yeah, quality of many companies' IP library quality is really low because they are not properly uh, designed, verified, simulated. No code coverage, no functional coverage. Regressions are really poor. Regression is just going to lab and debugging FIV signals, etc. Qualification is quite poor. System integration is quite poor. Just some specific directed tests such that you think it is okay to send your product to customer, but real world is not like this. So if you would like to do a high quality factor product, and if you would like to sell it to different customers, international ones, so then yeah, you need to follow some major steps. So conceptual design is what you, after planning, after having those clarified design requirements, after you really understanding them very well, then you start doing some researches, focusing on some ideas, drawing to whiteboards or your notebooks, so taking some notes, and you are seeking there for the best solution. Of course, you will see there will be some drawbacks, there will be some pros and cons during the implementation stage, but conceptual design is, the purpose is the best solution. But of course, you will consider your hardware, your software, as I mentioned, your ready-to-use hardware, ready-to-use software, intellectual properties. So you need to be realistic, but in addition to that, you need to seek for the best solution. You need to look for the best solution. So this is the conceptual design part. Then we have this optional step, conceptual design review by team leads and or system architect. I will again remove the system, and I will say architects, team lead. By the way, some teams, let me say, departments have multiple team leads, multiple FPGA design leaders sometimes. So I will say conceptual design review by experienced people, I will say, experienced colleagues. Because if this conceptual design fails majorly at some point, then it is not a good idea to continue with the implementation. So then, depending on the experience of that lady or gentleman, you may ask for the designer may ask for this optional step, or team leader of that person may give this decision, depending on the, sometimes, for instance, you are experienced, but you have no idea, no experience on that special topic. So this is the team's call, team's decision to either have such optional step or the other steps you customized and added to this flow. Just you may add such steps to your customized flow, let me say. So third one is implementation. Okay, this is really important because using the first two, you are now realizing your requirements. Of course, really important. This is really, I would say, after 15 years, extremely underestimated, reusing and producing reusable output. So it is reusing what you have, reusing your know-how in the company. Let's say your company is really proud of being 40 years or 50 years or 100 years, I don't know, but what you see, you cannot reuse anything. You cannot trust anything because there are many duplicates, many low quality factor designs there. So it is not acceptable. What the teams shall have, if they are compiling and using something, they shall improve quality of those designs. This is what we are doing at ASML. We are not only focusing on the new designs. You need to improve the quality factor of your legacy design. So it is like, yeah, this is, by the way, I had this many times. No one is eager to touch old designs. They say, okay, if there is a problem, I will touch. Then in that scenario, in that product, that somehow there could be many reasons. Those scenarios are not happening, or it is buggy. Already it is resulting in some errors, but no one is understanding, for instance, because its performance is low, or they accepted that is its performance of that product. So it doesn't mean that legacy designs are good. Of course, that should be an imbalance. You need to do some researches, cutting edge technology. You need to follow the latest news, etc. But if you don't touch your legacy designs, if you don't have a unique, nice, generic IPs, intellectual properties, then you are not investing in the future. Let me say, investing to the future, because you are then trying to integrate some old IPs, new ones, combinations. No one knows what is really going on there, because they don't know the capabilities of those IPs. They don't know how to use those generics, because the lady or gentleman designed that IP, even he or she was not aware of what they really do. They didn't get the requirements very well, and they didn't provide documentation very well. So this is not the mistake of one people in company. Actually, everyone working at that period is responsible from such failures. So as the ones, if you are sign a contract and accept you are working at a company, then you are responsible from everything you have in that team. So you cannot say, I didn't design it, I won't touch it. This is against team spirit, because then this starts, if someone does that, then everyone starts saying that. And of course, every time some more equal, more, that some advantages by knowing some people at the higher hierarchy of a company or something like that. They get some prioritization, they get better tasks, then that team start to collapse. Of course, they are there, they are going because they work, they need that money, but they don't really perform. That happens in many companies, majority of the companies in the world still, because it is managing people is really tough. So managers shall know that, and if they cannot manage, either they should resign from that title, or the company make them resign from that title. Because okay, we are saying managing is hard, but people really perform bad at managing. They insist on doing that. This is why, by the way, in 2024 we have really fast FPGAs like Versal or Agilex. Both are like kind of 9 nanometer transistor technology. They are really fast. You can run complicated design at 1 gigahertz on these FPGAs, but still we are suffering from, because I am discussing these with many people, international ones. Yes, I mean everyone, many different ones from different countries. So they are saying same thing. So they don't do cutting edge technology. They don't like the quality of the product. So they think they want to switch their company. What can they do? Blah blah blah. So similar problems. The solution is everyone shall perform as much as they can do. Okay. Sometimes it is of course possible. Your colleague is smarter. He is more hardworking. She is more hardworking. At the end of the year, your colleagues' outputs may be better, but you shall not compare and contrast yourself with others. This is your manager's job. Yeah, he or she, your manager, may optimize the ratings at the end of the year, but the best thing is improving yourself. So it is not like, if you, let's say, if you think you perform better compared to previous year, I think it is enough. So, but you need to always focus on your work. 8 hours of work shall be like 6-7 hours really focused. And if you, in FPGA sense, if you follow this kind of a structure, of course, in many companies, there are many nice rule sets, but they are only written and no one is checking that. So this is not acceptable. So if designers are skipping that part, then team leads, managers, group leaders, GLs, so they shall detect this. They are managers. They are there to do that. So it's kind of manager of managers. Then there's always some hierarchy in companies. So this is the brief error. This is the summary of the major failure, let me say. Everyone is doing that. Everyone is each company is trying to sell some products, get more income, but they are skipping this design quality. Verification engineers, they have the quality of that design verification. So it is, similar, but reusing previous outputs of the company and producing reusable outputs, that matters really a lot. Otherwise, each year, each 2 years, you are inventing wheel from the scratch, and it doesn't yet, that $1 million, $1 billion of companies are wasted. So that is why output of implementation is really important. Of course, there are many technical details we will be discussing in terms of FPGA design and verification, but output shall be like this. So simulation and verification, this is really important as well, because as soon as you go to laboratory for debugging, as soon as you go to the field for some debugging, you are wasting too much time. So that is why simulation and verification is really important. This step increases the design quality extremely. Of course, each and every step is important, but if you skip proper code coverage and functional coverage, then I would say, yeah, like if it is not that simple design, you will have lots of issues, or you will think that design is finalized and working properly, and you will switch to other project, and that project, that bit stream, that design will suffer a lot. So it is not like that. If that complex, or let me say valuable FPGA design and verification were not easy, were easy, then everything will be automatized. There are many tools like high-level synthesis, like HDL coder of, I don't want to give the name of the company, but they are not easy there, because if you would like to do on FPGAs something with low pipeline delay, like 30 nanoseconds, 100 nanoseconds, depending on the complexity of the algorithm, and if you would like to process huge amounts of data, bulk data, really fast at like 400, 500 megahertz, but you can do that in parallel. For instance, let's say you can run 100 processes in parallel. Okay, because I am saying 100 because I am assuming that this is a mid-range FPGA and each process is like moderate, medium level complexity, let me say. So it depends. You can also run one process for each transistor, but it is not feasible because with one flip-flop, you cannot. By the way, of course, many transistors forming a flip-flop, but let me correct it. You may run a parallel process, the synchronous one, let's say, because we will discuss that more on later, but majority of the design, other than ASIC stuff, FPGA design is synchronous design because it is more feasible because it is more trustable. Static timing analysis of that is, oh, camera is closed, sorry. Okay, it's got sleep mode. I am opening it. Yes, opened again. What was I saying? Yeah, more trustable because the static timing analysis tools are, due to many reasons which we will discuss more in detail. They are synchronous design is preferred, but we shall discuss more in next weeks. Depending on your design requirements, you also sometimes benefit from the asynchronous design as well. So, but this simulation, verification, code coverage, functional coverage, these two, if they have been made properly, even for the complex FPGA designs, you don't need to go to field for some debugging, or you don't have to go to lab for some integrated logic analyzer signal tap kind of debuggings. So this is why this fourth stage is, like all others, this is really important. Outputs are simulated and verified design via self-checking test bench. We have a lecture about this. We will be having self-checking test bench class in the future during the next classes. But this is important. Simulated and verified design shall be via self-checking test bench, custom libraries, and depending on your team's preference, universal verification methodology, universal VHDL verification methodology, open source VHDL verification methodology, /CocoTB, there are also some other approaches. So this is depending on your team decision. So there are of course pros and cons, but the most universally accepted one is UVM. This is the best one. But others has some pros and cons in terms of many things, like cost, like make it up and running time, finding engineers that can handle these operations, these methodologies, etc., etc. We will be discussing them more during next classes. So fifth, this is also, in my opinion, one of the most enjoying parts, and I love the fifth one, resource and timing optimization. This requires experience. This requires actually being a good teammate, being a good colleague, being a good person. Because if you don't discuss, if you just individually try to do everything individually, I think you can do these steps, but quality of each will be much worse compared to being a active, positive attitude person, because you learn by discussing, you learn by comparing and contrasting with your colleagues in a nice, friendly environment. So, but the resource and timing optimization is really enjoying. I love, as I mentioned. Outputs are constraint files. So you need to have, depending on the technology you are using, that SDC, Synopsys design constraints, XDC, Xilinx design constraints. Old one, like the Xilinx using when ISE were there. 14.7 was the last ISE Xilinx EDA tool. It is still using, by the way, so let me use the present tense, UCF, user constraint file. So it is the STC and XTC. They are, by the way, STC is used both by Altera and Microchip. XTC is used by Xilinx, but actually that STC Synopsys design constraints is just created in the past, like 20-30 years ago. I don't know the exact date by heart, but it is created to manipulate, to give some commands to design tools of Synopsys. So what we have today, okay, it is SDC, but not only Altera, but also Microchip SDC support is superset of that SDC. So each, they are tickle script based, and those constraints are provided there. Okay, that base is like base class is, let me say, in an analogy with object-oriented methodology is Synopsys design constraints, that language templates, etc. But each and every tool, every vendor, let me say, created the superset of those because they have written their own synthesizers in years, especially the Intel Altera and AMD Xilinx. So for instance, like 20 years ago, Xilinx ISE tools like ISE, I remember 4.2, it was using a tool called Leonardo, for instance. And for many years, Actel, then they renamed, it is renamed since another company bought it, Microsemi, then Microchip acquired them. So they were using also Actel ones, so flash-based FPGAs, they are, other two is RAM-based. They were using Synopsys for synthesizer. Maybe still they are using Synopsys. To be honest, I haven't used Microchip FPGAs. They were calling them CPLDs in the past. Now they call FPGAs because they improved some structure, but still they are flash-based. Maybe they are still using Synopsys synthesizers. I am not sure, but right now, Quartus, which is the EDA tool of Intel Altera, they are using their own synthesizers. Xilinx start using their own synthesizers, I think, earlier than Altera. So yeah, this is why they are the superset of the that first SDC Synopsys design constraints. But you need to, those constraints files really important because you provide your clock frequency, your design details, your design exceptions, like false paths, multi-cycle paths, input delay, minimum, maximum delays, output port minimum, maximum delays. So if you would like to do a synchronous design, either source synchronous or system synchronous, so you need to know those constraint files very well. Actually, you need to know tickle scripting. TCL is tool command language. We have classes about these. And then you need to know the superset, the specific commands for your EDA tool. And then you need to fully constrain the design very well. And resource optimization is, of course, really important because each time you don't optimize your resources, you will you need to use more and more internal resources of FPGAs, then you will look for a more expensive one, either in terms of speed grades, either in terms of more dense package, same size, but sometimes the size are different. You need more pins, or since you need more resources, more DSPs, more ALMs, more CLBs, so then you need to switch to a bigger package, larger package. So optimization matters a lot. Then you may run your design with, if you do a resource optimized, well optimized design, then you will perform, realize the requirements, realize the algorithm you are supposed to implement with the fastest clock frequency and minimum resource usage. So that matters a lot, because it is, you are taking, sometimes you are the first designer of a chip, let's say you got a new project, and the FPGA is, at that time there is no code implemented, so it is an empty project. But as that design improves, so the resources, you use more and more resources. So that planning, by the way, this fifth step. As you see, there is a strong relations with first three. So simulation verification. Okay, if you did well, planning, conceptual design, and implementation. Okay, simulation verification is to verify the design on the desk, on the desktop PC, on the servers, etc. But resource optimization, timing optimization, that matters a lot for that specific chip. So depending on your design requirements, then you may need to change your FPGA package, speed grade, etc. So it is the transistor technology, by the way. Yeah, it's a little bit more or less same technology, but if same package, same FPGA family is capable of faster working transceivers, then we call it, its speed grade is better. So and of course at the end they are more expensive, because they require more complicated processing, let me say, producting kind of. So the outputs, again, let's say constraint files, fully constrained design, optimized resource usage, and timing performance, as I tried to mention. So sixth one is design and code review. This is extremely important, because you see we try to do in three by reusing and producing reusable outputs. If you don't do this design and code review stuff, then you fail so hard, because otherwise, if no one is checking what you are doing, then you can do whatever you want, and you may say that it is working, and if it is partially working, you may persuade some people that it is working. You may live in a, act like in a theater, but at the end, quality factor is there. If it is 3 out of 10, it is 3 out of 10. So, that's telling lies, or not knowing the details, not being experienced, or even if it is experienced, not being a good FPGA designer or verification engineer. So it doesn't mean quality factor will increase. So that will, if it is 3, if it is 2, that will be that number. So it is quite important. Of course, we will discuss some details during next classes, but there are manual and automatic reviews. By the way, in our channel, we are also doing some code reviews. We did some in Discord also. We made a live stream last week for HDL code review. I plan to do it in English as well. if I have enough time. Let's see. And if some people would like to have it. But there are manual and automatic ones. For automatic ones, you use some custom solutions of your company written by C++ or Python, or name it, whatever that company used, or you are buying some linting tools. Yes, they result in, as I mentioned there, improved reusability and know-how transfer. Otherwise, yeah, that's great know-how of experienced people. Probably if you're at a good company, in a good company, then they have worked in great projects. If you don't do this kind of design and code reviews, then that know-how is lost. So this is quite important. So seventh one, regression qualification system integration. We also have a class. Oh, actually, for each step we have some class. We don't have documentation specific class, but it is easy. I will mention that very soon. But let's focus on, we have, for instance, regression qualification system integration class. So we will explain some more details. But you are doing some regressions using different tools. Actually, here that's for each of these sub-steps, regression, qualification, system integration, there are many great tools. Continuous integration, continuous deployment. Actually, they call it right now continuous delivery tools. Okay. For your own design, the design you had, you may run lots of regressions using the tool you have in your company. Like for simulation verification, you may use, let's say, Questa Sim simulators. For clock domain crossing, you may use Questa CDC. For linting, you may use Questa Lint. For reset domain crossing, you can use Questa RDC. Also, for hardware in the loop, software in the loop test that involve at some level real softwares, real hardwares. Okay, you may use some other customized Python-based, XML-based tools. You may integrate, yeah, C++ based ones are also there. You can use tickle scripts, many of them. You can use make files to build that environment. But starting from a part of design and up to that, let me say, FPGA chip, then it is regression we usually call. Then qualification is that device, that product. Usually it is not the huge, it is not the whole product, but a part of product. Let's call it LRU, for instance, line replaceable units of a bigger system. Then you do qualification. Regression is usually on servers, but qualification, you need some real hardware. But also regression may include some, as I mentioned, software in the loop, hardware in the loop stuff. So here you see regression test via simulation plus simulation is not only simulation here, also it may include like other design analysis and diagnosis and solutions provided, like for instance Questa CDC is a good example. It in-depth analyzes clock domain crossings in your design and provide you some messages with different levels of severity. So this is possible, not only simulation, but regression tests. I will also change this simulation part. I will add a few details here. Also, I was going to change this system architects here and here to architects. I will remove the system, delete the system part, as I explained. So qualification is more like product level, but could be a part of product as well if it is a huge system. But it should be on real hardware somehow, because you are qualifying your design in terms of like temperature, timing, performance, the performance parameters, bit error rate, etc. So you may use, for instance, during qualifications, some oscilloscopes, some digital analyzers, etc. Of course, you need to connect them in a proper way to a working PCB board. PCB is already board, right? This was wrong. So PCB, printed circuit board. So PCBs as well. Let me correct. And system integration, if it's a bigger system, which is consisted of many line replaceable units. Sometimes it is not line replaceable, by the way. You cannot easily remove and change it, but it is then much harder to do that qualification and fixings, etc. Also debuggings. So this is, I think, more or less the first 7 steps, and 8 shall be really easy. Yeah, I know many people hates this stage, but it is actually what I've seen, especially during 5-6 years of my career. If you do some solid approach like this, if you have nice 7 steps, then documentation is only 1-2 days, because you have really many those green blocks you see outputs. Then, as I mentioned, design documents, either it's a design verification or design itself. So these, depending on the companies, there are different document names, but at the end you have these outputs. So extremely benefiting from the outputs of first 7 steps, then it will be really easy to end up to conclude the documentation. Sometimes, yeah, one company has multiple, some has 1 or 2. Yeah, it depends on the company decisions made in the past or the current updates. But yeah, believe me, it is, even if you do a really complex cutting edge FPGA design and verification, if you follow these steps, you will not spend too much time on documentation. It will be fine. So just you will see while you are experiencing it. But if you do each and every first 7 steps in a well organized, good way, then documentation will be really easy. So this is the first 7 part. Sorry. This is the whole of this FPGA design and verification flow. So we have 8. We have an optional step here. So let's say 8.5 steps. So of course you will learn a lot. FPGA design is not straightforward. Verification is not straightforward. That requires some hard working and motivation, self-motivation. You shall have good colleagues. Otherwise also, yeah, as I mentioned at the beginning, 1-2 people is not enough for achieving high quality, complicated, valuable FPGA outputs. So this is complicated. There are many subparts that we will be discussing. Yeah, most of them from a big picture, let me say, during these 30 classes. But it is really important. Team spirit is important. Also, yeah, you need to know about other disciplines as well. So this is not an easy progress, let me say. But yeah, there are also many great FPGA design and verification gurus in the world. So it is not something impossible to achieve. But I think, yeah, for instance, I have been working on this for 15 years. I love it. I enjoy it. I love learning from young people, new graduates, or even students, because they have bright ideas. Also, I love discussing those details with people at my level, also the guru ones, of course, because they have huge experience, like 30-40 years FPGA design, and at some extent verification people are in the world. You can reach them on LinkedIn, you can reach them through some seminars, to many also trainings, etc. Sometimes free of charge, sometimes paid ones. It depends on your companies or your budget to invest on these. But to be honest, yeah, it is quite enjoying. I love, after 15 years, I love my expertise, what I've learned, what I am doing. So yeah, I will assure you it is really enjoying. So don't give up, keep working, you will make it. So this is the summary, I think, for today about the design and verification flow. I have one more slide about, yeah, this. Let's go back to the agenda. Just a second. Yes, this only we have this task version management plus CI/CD. So I have a slide regarding to that. I think that one will be much shorter. Let's have it and finish this lecture, and like then if I have it in 5 minutes, 45 minutes later we have the Q&A class. So I am expecting some questions, but the length of that depends on your question. If you don't ask anything, I will just review these slides and finish maybe in half an hour. But if you ask more questions, I am eager to check try to answer your questions. So task actually, since it is so long, I try to little bit shorten it. So it is task management, version management, and CI/CD plus CI/CD. So this is 3 major points to be able to make that 8-step possible with a high quality. So task management is the tool you are using. So here on the right side you see example tool combination. Task management tool, very well known, frequently used by many companies, is Jira. Also there are some other alternatives. You may just type Google task management tools and you will get many. But Jira is great, to be honest. I love it. Version management, there is Git. So Git is also a great tool. There is that submodules approach. So it is possible to really manage well the components you are reusing. Also the merging system of Git is much better compared to SVN. Subversion, full name is, this is the SVN is the acronym of the subversion. So yeah, Git is, by the way, distributed. SVN is centralized version management system. I am sending right now a nice web page of Git. So it is explained very well here. So just check the documentation, etc. So I also really love Git. So my recommendation, don't waste your time too much on other version management tools. Git is really getting much more popular nowadays, and yeah, majority of the people using Git is Git. Majority of the people that are using Git are loving it. So I would say for the version management, Git is quite solid. But of course, depending on the company you are working, if they are forcing to use SVN or some others, then you may need to follow. But of course, you have freedom to tell this opinion to your colleagues. Maybe at some point you will switch. So don't be negative about that. So that happens. So not every company has the most recent approach, but it is good to discuss it and improve not only design quality, but also infrastructures of your company. If you don't have infrastructures to achieve what I've explained until now, then you need to go for it. If you don't ask it, if you don't tell them, these are much efficient. Of course, you can. There are really nice reports on the web. You may also show those results. Then that will be an improvement, huge step for your company. Don't think always like design and verification. The code you are writing is the most valuable. Sometimes an idea, sometimes an approach is much more beneficial for your company, for your country, etc., for your team, etc. So try to get this mindset starting from the early ages of your engineering or any discipline you are working on. Maybe you are not an engineer. So Jira is version management. I think the middle one is quite solid. Sorry, Jira is task management. For task management, you may use some other tools, but I love Jira, as I mentioned. I love Git for version management. I mentioned it is quite, this is, I think, there are not that good alternatives to Git. Plus CI/CD, there are also many different free of charge and paid CI/CD tools. Jenkins is, for instance, open source and quite good, but due to some other reasons that we will discuss a little bit in the future, Jenkins is not that popular nowadays. But Bitbucket, by the way, Jira and Bitbucket are Atlassian. So this is the company. The integration of Git, Jira, Bitbucket is quite good. I would say it is like too good. Because you can, for instance, anything you commit or push, commit and then push to server, any design change, any version management change, let me say, everything is possible to follow on Jira with a simple command hash you add there. Also, there is a great integration because they are both Atlassian, between Bitbucket and Jira. So you can start any regression, any compilation using your servers that connected to Bitbucket. So these three are also, you can see again, like Jira, you can see each commit and hash numbers of that commit on Bitbucket. So they are really, this combination is really golden. I love it. Of course, you may switch Jira with another one, another task management tool, Bitbucket with another CI/CD tool. There are some other options possible. There are some custom options are possible also depending on the company you are working. But in general, for the final product you are buying, I love this Jira, Bitbucket, and Git tool combination. So example task management tool usage for the beginners. Okay, the experienced ones probably knows it. Hopefully they are using some task management tool like this. But this is not Jira, by the way. This is a free of charge tool available on the internet as well. Kanboard Weave. So this is free of charge. This is not as good as Jira, of course, because Jira is not free of charge, though free of charge versions are available, but the best features are require some payment. Both Jira and Bitbucket are not free of charge. Their best features are not free of charge, but still there are some free editions available for Jira and Bitbucket. Git is already free of charge, but you require some servers to be able to properly use Git, so that you can share it with your colleagues, that database, and you can pull and push codes to those servers. Of course, there are some additional security stuff on those servers. Also, those servers are backup as well. So this is the company way of working. But Yeah, this Git, I would say, free of charge. Jira, Bitbucket, they require some monthly, yearly payment depending on your subscription. But this is a free of charge one. So you have a example, we see here example task management tool usage. Project A, let's say, task one. So this is let's say this is a design task. Then subtasks of that design is determined, like that planning, conceptual design, implementation, simulation, optimization, testing, review, documentation. This is a little bit different from the 8th step I mentioned, but as I told you, that may change depending, of course, on your team or company. So, but 8 steps, design subtasks. So there is time tracking, so assignee here, and you do daily, once per 2 days, 3 days, depending on the complexity of the design. So you do some comments. Your team leader follows these comments because each comment is emailed directly to your team leader, and the ones interested in this task they called watchers, and you, of course, yourself. So every recommendation, every comment is tracked by each and everyone, assigned, added as assignee, assigner, and the watchers in the list. So it is a nice tracking, actually checking of the design stages, checking the design progress. Then not only designer, but also, of course, team leader plus the watchers, other colleagues, they are involved this design progress. Then if designer follow these steps properly, quality of the design or verification is really high. Okay, so it is like you see, I mentioned to suggest and recommend different approach. This is also quite valuable. As you see, the guy on the left gives some wheels. There are the square ones here. You see the guy. Probably this is another engineer with the analogy. He says we are busy. You hear this word by this sentence too much, by the way. And team leader is just I think this is the since he is carrying this stuff, but the guy on the in the middle, he says no thanks. This is the team leader, I think. Okay, and this guy, one engineer, either experienced or inexperienced. So some great comments, ideas are coming from people with different experience, but it is the ideas matters. So of course, at some point, to be a team leader, you need to have years of experience as well. So this is combination of everything, but it doesn't mean that if you have 20 years of experience, then you shall be the team lead. Of course, this is also wrong. So yeah, this is something that shall be kept in balance by the managers or the group leaders. So this is another story, but you know, here the great idea is provided, and these two guys are rejecting it. So this still happens a lot in 2024. That is why it is quite important to benefit from technology, watch this kind of free of charge classes, etc., and attend some seminars, either free of charge ones, paid ones. You will be, if you follow these recommendations, I think you will be a much better engineer in a really shorter time compared to others that are not questioning, not asking questions, not curious after some years, etc. So I am suggesting you to follow this path. So this is the end of the first lecture of these 30 class English, fully in English FPGA from zero to hero courses. Thanks a lot for listening, attending. Now I will rest half an hour. In the meantime, you may prepare some of your questions. So I will be online again at 1 p.m. You may ask any questions either through Discord link, because I will connect Discord, so everyone will be able to hear your voice. Everyone watching this live stream will hear your voice, so you can ask voice questions or text questions during the Q&A session. So thanks a lot, and like see you in 35-40 minutes kind of.